things I would like us to do is open up to page 389. 389. So some of these equations are a review, and some of them is new material. But in 13.7, it's called the oxidation with that of alcohols. Okay, we're going to skip all the way down to, well, below that combustion reaction. It would be the second paragraph down. It just says selective oxidations. That's where we're at on page 389, underneath 13.7. Okay, selective oxidations of organic compounds are oxidation of a weaker bonds in the molecules, whereas combustion transforms an organic compound into carbon dioxide and water. And that's something that you learn in physical science, and you did that again in general chemistry, and now it comes full circle again here with organic chemistry. Okay. Carbon dioxide, water. Selective oxidation transforms the organic compound into another organic compound, a member of a different family. Okay, now, such transformations are important in biological systems as well as in industrial processes. Okay, especially probably one of the, what I would think is probably one of the most important industrial solvents that's not only just made but maybe even used. And it's something that you use to take your fingernail polish off should you choose to put that on. Of course, well, fingernail polish remover. No one would argue with that. That's true, but what do you think that ingredient is? You know, starts with an A. Its acetone is a common name, or it's actually called 2-propanone. Okay, is actually, I believe, what acetone actually is. Okay, so in an alcohol, the weaker bonds of the OH or hydroxy compound and the adjacent carbon and hydrogen bond. Okay, it breaks between those two, and the weaker bonds are the bonds that undergo selective oxidation. Two of the most commonly used selective oxidizing agents are permanganate, which is MnO4, but we just choose to write it as, it would be KMnO4. And then the other one is Cr2O7, where here we see potassium dichromate. That's another oxidizing agent, or K2Cr2O7, which has a -2 charge. Primary, secondary, and tertiary alcohols behave differently under selective oxidation conditions. Primary alcohols are oxidized in 2 stages, and that's why we were saying, I can't stress that enough, to be able to recognize the difference between a primary and secondary alcohol. Okay, so stage 1, simultaneous loss of hydrogens called dehydrogenation from the OH group, and from the carbon holding the OH produces a carbonyl group, as shown in the next equation. The resulting compound is classified as an aldehyde because NH, or anhydrogen, is attached to the carbonyl carbon. Okay, so as we flip the page, it's showing you what those 2 stages are. Now, you have a set of reactions that show you. It says stage 1 and stage 2. It shows you what's happening, and that's what we're trying to illustrate here on the top of page 390. Okay, so in stage 1 in a primary alcohol, if you have an oxidizing agent like this, what is the first product? Starts with an A. It was aldehyde. That's right. Okay. Then what we see happening, okay, because when it comes to a primary alcohol, okay, we'll just keep this fairly simple with that of methanol. Then what we had said is what will take place is this gets stripped off of there. That's a weak bond, and then also this one as well. And then what happens is notice that, oops, excuse me, you got to take two of them off, then there's a double bond there. I was right the first time. There. So notice we've got 1, 2, 3, and 4. And then that would be that of an aldehyde, to where these two hydrogens are stripped off. And if we have a double bonded oxygen, okay, that's on the end, we know that's an aldehyde. Because what happens if you have a double bonded oxygen other than the end, that is called a what? Not an aldehyde, but a ketone. So that's what we're trying to illustrate here in stage 1, where them hydrogen atoms are stripped off of there. Okay? In stage 2 then, and I don't think it goes on to state why does this continue? Why does it not stop? Maybe it says that in the next paragraph, but in stage 2, oxidation of the hydrogen attached to the carbonyl carbon to the OH converts the carbonyl group into a carboxyl group. Okay? The resulting compound then is a carboxylic acid. So remember, primary alcohols follow the stage: 1 to an aldehyde, 2 to an acid. Oxidation with permanganate or dichromate, okay, proceeds from the primary alcohol all the way to the carboxylic acid without stopping at the aldehyde stage because these oxidizing agents are too strong. Well, there's your answer. It's too strong of an oxidizing agent to stop. Okay? For situations in which the aldehyde is the desired product, the reaction can be stopped as the aldehyde stage by using oxidizing agents that are milder than permanganate or dichromate. Okay, so there's your answer. But up to this point, these are only two oxidizing agents that we're referring to. This one and that one, okay? The permanganate one and the dichromate, okay? But these are the only two that we've dealt with, and I believe the only two that we will deal with. Okay, so now we see secondary alcohol oxidation follows a simpler course than the oxidation of primary alcohols. Oxidation cannot proceed past the carbonyl stage. Okay? The product with a carbonyl group is a ketone. Okay? Note that the ketones and aldehydes both have a carbonyl group. An aldehyde has one hydrogen and one R group attached to the carbonyl carbon, whereas a ketone has two R groups and no hydrogen attached to it. So what you're seeing here, we see two R groups with no hydrogens on there, and that's how we know that is a ketone. Either you can say it's a double bonded oxygen with no hydrogen, but we just usually associate it with a double bonded oxygen somewhere other than the end. We know that's a ketone. Okay. Because a ketone lacks an H, that's what it says in the book, because a ketone lacks an H or an hydrogen attached to the carbonyl carbon, there's no further oxidation under selective oxidation conditions. The hydrogen attached to the carbonyl carbon in aldehyde is oxidized in the second stage. Okay. In the second stage, we're talking about primary alcohols. That's what they're referring to. Don't think there's a second stage for secondary alcohols, because there is not. There's only one stage. Okay. Tertiary alcohols cannot undergo selective oxidation because no hydrogens attached to the carbon with the OH bonded. Okay, the OH hydrogen cannot be lost by itself. So do we see why tertiary alcohols can't oxidize? It's got that blue writing where it says the carbon does not have a hydrogen, because what's attached to that carbon? You see, what's R, R, and R? Alkyl groups, right. And then, so you have one on the bottom, one on the top, and one to the left are all alkyl groups. So then what is the to the right of it then? an oxygen, a hydroxy group, oxygen, a hydrogen. So with that carbon that has the oxygen attached, there is no hydrogen to strip off of there to oxidize. So there is your definition, in essence, in a chemical definition of why tertiary alcohols do not oxidize. So if you see something like this, then this would be the simplest, plus KMNO4, what happens? We went through that real quick, but what do you think happens? What type of alcohol is this? X marks the spot, 1, 2, 3, and tertiary alcohols can't do what? They can't oxidize because notice there's no hydrogen on here. When we look at this guy here, okay, notice this has some hydrogens to strip off of there, where this one does not. It's all carbon groups. Okay, that's why tertiary alcohols cannot oxidize. Okay, so we'll get these knocked out and get you on your way. This is kind of a review. Okay, what do we have here? 1, 2, 3, 4, 5. So what is this? It's an alkane, it's pentane, and we've got a halogen, but is there something missing there? What's true about alkanes? Are they highly stable or are they highly unstable? They're highly, highly stable, okay? So if that's the case, well then we need something like this. Okay? We need to have some sort of catalyst to cause this to take place, and it's on your equation sheet or your flow charts. What do we see happening? We still have all of these carbons but somewhere along the lines, one of them hydrogens got pulled off of there, and what's going to take its place? I'm going to put a chlorine there, okay? And then how many of these do we have? 2. So we've got plus HCl, okay? Now, we'll be going over more of these. We just don't want to all of a sudden wait till the end of the semester and start throwing these in here. But just a slow and steady progression here. Okay, so the first thing, we're not worried about the name of that alcohol. The first thing that we want you to do is recognize, yes, it's an alcohol, but more importantly, what type of alcohol is that? It's kind of tricky, I'm not going to lie. That was intentional. How rude on a Tuesday morning. So if nothing else, just do what we've been doing a lot this semester. Say, well, X marks the spot here. Okay, there's our hydroxy group. There's the carbon that attaches to it. That carbon attaches to how many other carbons? 1. So that by definition then is a what type of alcohol? Primary. Okay? It looks kind of tricky thinking, oh, that's a secondary alcohol. No, it's not. It's still a primary. Because the parent chain, does it go in this direction? Is it a straight chain or a branched chain? It's branched. Actually, it goes up and over. How would you know that? Why can't it go this way? Because we wouldn't know how to name this. This has to be part of the organic family. So this is telling you where to start, and it's a primary alcohol. How many do we have enough room? Is there going to be 1 stage or 2 stages for a primary alcohol? There's going to be 2. What is your end product then. If not, you just look on top of the page there on 390, I bet. Yeah. So, but there's an intermediate stage. The end is an organic acid, that's stage 2. But stage 1 is what? It's an aldehyde, that's right. Because remember, what we see happening is this gets stripped off of there, and what else? Because of these weak bonds. Well, it's going to form a double bond, that's true, okay? But what's happening to one of these two guys? They're going to disappear as well, okay? So put a box around him, that hydrogen. So what we see happening then, 1, 2, 3, 4, 5, okay? So we'll put this a little smaller. Okay, we'll stretch that out a little bit, this carbon-to-carbon bond here. Okay, all these hydrogens are still there. Okay, so this hydrogen is still here. This oxygen is still here. But how many bonds does that bottom carbon have? It only has 3. How many does it need? It needs 4. Where's that other bond going to come from? Because what does it mean to be an aldehyde? Yeah, double bond on the oxygen. There we go. Okay. Then, when this proceeds further, because what we read earlier, it's a powerful oxidizing agent, we see this happening again. We'll go down. Okay, so now what we see happening, there's that carbon-to-carbon stretch. Okay, what happens to this hydrogen? Okay, it adds an OH group to it, and then there's our double bonded oxygen. That's right. So stage 1, aldehyde, stage 2, acid. And then, again, that can be found on your reaction flow chart here that's written in green. Okay. Then on the bottom, okay, it says oxidation of secondary alcohols, but here we don't have an oxidation. This is more so of a reduction, because when I was making this list, I was looking over at our planning board, and I saw oxidations and reductions. That bottom green reaction is actually a reduction, not a oxidation. So we will pick up with that tomorrow, because Wednesday you'll have time to work on these, okay? And then I didn't notice the length. So tomorrow, yes, you can work on these. I was going to take this and assign it, but I think I'm going to move this over to Thursday, and then we'll see once where we're at for there. Okay? So just keep that in mind. So again, the take home, you didn't tell me about the lights. That's twice now. But then it's my responsibility, right? Here comes the buck. Here comes the buck. There it goes. You know what that means? You've never heard that before, have you? It's called passing the buck. That means when you pass the buck, it means you're passing the blame. And it was Dwight D. Eisenhower that was known, I think that's right. He had kind of like a nameplate, or not a, you pictured nameplates that would say like Dwight Eisenhower or D. Eisenhower. He actually had a plaque on the desk, I think, that said the buck stops here. So anything where you're blaming something, he's saying you start with myself. I think that's kind of profound information, maybe useless information for you people. That's something you can quiz other people with. Maybe it wasn't even Dwight Eisenhower, but I think he said the buck stops here. Okay, we'll pick up with this tomorrow.